Hello everyone and welcome to um, our prep lesson today. Okay, so what we're going to do in this lesson is what I've done is I have selected some key multiple choice questions under each of these topics. I hope you have seen the syllabus. Okay, this is the syllabus for IGCSE 0625 Physics. And these are the topics. So I've selected, under each topic, I've selected about 3 to 5 or 6 questions, key questions that we can use, and I will show you certain uh, good practices in order to do well in the upcoming paper 2. Now, at the time of this recording, yeah. At the time of this recording, the paper 2 for physics 0625 will be held sometime next Monday, all right? On can't remember, on the 16th of November. So this session is meant to help you to do a bit of revision and for me to give you some tips on how to answer some questions if you're still unsure. And please keep the live chat active. If you have any questions, just ask. And I will definitely pay attention to it and answer your questions. All right, so we're going to get started with our first question. Now you will need some time to read the question, so I will answer after about a minute or two. So this is our first question. Now, if you have any questions, right? If you have any questions, I can't type and chat, okay? So I'm going to answer using my voice, all right? So you got to pay attention to that. All right, let's get started. Now, I hope you know the difference between a barometer and a manometer. I hope you know the difference, yeah? Now, can anyone tell me what the barometer is used for? Can anyone tell me what the barometer is used for? Okay, so the barometer is used to measure atmospheric pressure, okay? And the manometer is to measure the pressure of a gas supply, and this gas supply would probably be in a fixed container. Yeah, absolutely right. Okay, so looking at this question here, all right, let's look at this question. All right, so before we go there, all right, let's say the liquid levels are the same. All right, so what is the pressure here and what is the pressure here? All right, so the pressure on both sides are equal and the pressure will be the atmospheric pressure. Okay, now what happens is that what if one side goes down and one side goes up? What does this mean? All right, it means that the pressure on both sides are not equal. All right, so you need to identify which side is experiencing the higher pressure. So of course this is lower and this is higher, so the pressure here will be greater and the pressure here will be lower. So that's what you need to understand. Okay, now let me give you another situation. All right, so let's say that let's say on this side, yeah, so this is connected to a gas supply, and what you have is, all right, so this side is higher and this side is lower. Now you need to understand that on this side is atmospheric pressure and on this side is the gas supply pressure. Now, which side is experiencing a greater, higher pressure? Which side? Thank you for all your live chats. I'm looking on it. Yeah. Okay, so in this case, in the final diagram that I drew, so is the, yeah, which side is experiencing the higher pressure, the left or the right? Yeah, so thank you, Jared. All right. Now, in this case, you will have more experiencing more pressure on the right. Okay. So then, um, the pressure of the gas supply is equals to the atmospheric pressure minus since the gas supplies pressure is lower than the atmospheric pressure. Now, minus what? Minus the excess pressure. But what is the excess pressure? So the excess pressure, okay, so the excess pressure is pressure due to the difference in height of the column. I repeat that, yeah. Excess pressure is pressure due to the difference in the height of the column. Now let's look at the question now. Now the difference in height in this question is, all right, now, so now you have the question whereby you have the gas supply, all right, and the difference in height is 20 centimeters. So in this case, we know that this is higher and this is lower. So this experiences lower pressure. Now, if they are asking us, all right, what is the pressure of the gas supply? Well, the pressure of the gas supply will definitely be atmospheric pressure plus, because you said that it is higher, right? So it is atmospheric pressure plus the excess pressure. And what is excess pressure? Excess pressure is the height due to the column of liquid. So yes, the answer for this question is the atmospheric pressure plus the height difference. Now, what is the height difference? Okay, it is very clear. It's even in the question that the height difference is 20 centimeters of water. So in this question, the answer will be D. Okay, so for this question, the answer is D. D for donkey. Now I'm going to look at the live chats. Yeah, any questions you have on this before I move on? Are you okay with the first question? If you have, please type away. Type away. Yeah. Any questions you all have? Okay, if not, we are going to move on to our next question. Have a look at the next question. So we are still under general physics. Okay, so this is actually a simple question, but this can be quite confusing because reading graphs is not second nature to a lot of students. Okay, so you need to be focused on this question. Yeah, so please. Thank you, Jared. Thank you, Jared. Now, looking at this question now, what is the thing that, what is the theory behind this question? We know that mass, all right, mass is constant. Okay, we know that mass is constant, but weight. Now, weight depends on, what does weight depend on? Write the answer in the live chat. What does the weight depend on? I hope you know that they are not the same thing, okay? They are not the same thing. So what's the difference between mass and weight? What is weight actually? Weight depends on, okay, weight depends on gravity. Yeah, very good, Kylie. Gravity and mass, you are right. Huh? But in this case, there's no but. In this case, yeah, gravity depends on different locations, okay, on the same planet. But we're talking about two different planets here. So it's really depending on the size of the planet. Okay, Now, let's look at the question here. So now we are talking about planet P. I think the graph on planet P, yeah, so this is planet P. Now, here would be 400 newtons. Now, because you know that the mass is constant, therefore, they want you to get the mass from the 400 newtons. So what is the mass? So from the first line, they want you to get the mass, which is how many kg? How many kg is this mass on planet P? Come on, let me see your answers. Yeah, it's 40 kg. So now the role of the first line is to tell you that the mass that we are talking about is 40 kg. And now the 40 kg is taken to planet Q. All right. So a lot of students, what they will do is, all right, they will follow this point, and then they will get the mass of uh, the object on planet Q, and presumably it's 80 kg. Well, this is wrong. Okay. Now you're supposed to follow the mass which is constant. So we will go. So we will follow 40 kg, and actually this is the answer. Okay, and if you do that on the question there, you can very clearly see that the weight of the 40 kg mass on planet Q is how many newtons, guys? How many newtons? Yeah, um, the chat is not appearing on my phone, so I need to toggle between the two of them. Yes, yes, yes. No, the chat has no delay. I did not see. Okay, very good. Yes, it's 40 kg. So can you answer the next one? Yeah. So what would be the answer then? If the mass is 40 kg on planet Q, 200 newtons, amazing. So now the answer for that question will be A. Yes. So the next one will be A. Okay, so A is the answer. I hope you all are clear about that. Let's move on. Let's move on. Huh? Okay, so now we are getting started. So if you have any questions, just keep them coming. Just keep them coming. For the year 10s who are with us, welcome. All right, and this will be relevant for you up to a certain point. Huh? But actually, yeah, up to 80-90% of the whole thing. Now, the next question, Hooke's law. I hope you all know the definition of the explanation for Hooke's law. Yeah, you all know the definition of Hooke's law. All right. So now, what is the value of the spring constant? Now, firstly, um, yeah, let me see. Yeah, okay, no one is chatting. Okay, so yeah, so basically the formula for this question is, guys, do you know? Yes, thank you. Can I know who is that? Who is that with the yeah, the F? Who is that? I don't know who is that. F equals to kx. Yeah. Uh, if you are that person chatting, thank you, Jesslyn. Yeah, thank you. You can. I will upload the video later. You can watch and have fun. All right. Thank you. Thank you. All right. So F equals to kx. So that's absolutely correct. Okay. So what a lot of students will do for this question is they will take 4 equals to, okay. Hi, Adam. Thank you. Thank you, Jesselyn and Jared. Okay. So K times 20. Okay. So many students will do that, but no. Because 20, because you have to understand that x is supposed to be the extension. All right, so x is supposed to be the extension, and 20 is not the extension, because if you look at the x-axis, the quantity on the x-axis is the length of the spring, not the extension. So how do we get the extension? Well, I hope you all know that the extension is equals to the length of the spring minus the unstretched length. All right. So length minus unstretched length. In this case, the length is 20 cm. But what is the unstretched length? Looking at the graph, what is the unstretched length? Can you key in the unstretched length in the chat, please? What is gradient? Yeah, you are right. You can use the gradient as well. But can you tell me what is the unstretched length? Very good, 4. So it will be 20 minus 4. So the extension is 16. Now this is for the 4 Newton load. Okay, correct. So now we will do the formula again. So 4 equals to k times 16, and k equals to 4 over 16. So it's 1 over 4. So it's 0.25 Newton per centimeters. Okay. Adam, I'm getting your live chats. Okay, I don't think they are very much delayed. Okay, yeah. Okay, so uh, the answer for this question is boy. There we go. So the answer to this question is boy. Okay, if you have any questions regarding this particular question, please, I'm looking at the chat. Keep them coming. Any questions for this particular question here? Hooke's law, anyone? Okay, keep them coming. I will answer them if I see them. Now we are going to move on to our next question. We are still under the first topic, general physics. And this is just a basic question. This is just a basic question. Can I get you to key in, to enter the answer? What do you think is the answer for this question? What do you think is the answer for this question? Let me look at your answers. Extension, Jared. Okay, Jared is extension. Yeah. Okay, can you key in the answer to the next question? Can you key in the answer? D. And yeah, you're absolutely right. Because what is the biggest length that the micrometer screw gauge can measure? Do you all know? Very good. Yes, it's donkey. Yeah. Do you know? Thank you, guys. I got your answers. Now, can you tell me the maximum length that the micrometer can measure? Do you all know? It's not very important, but yeah, it's good to know. You all are absolutely right. So the micrometer screw gauge is suitable to measure the thickness of the glass wall. So my next question is, what is the usual maximum length? Oh, you don't know? All right. So the maximum length that a micrometer, wow, that's small. It's 25 mm, guys. Okay, so 25 mm would be 2.5 cm. So normally the micrometer screw gauge can measure up to this length. Yeah, so the answer is D. D for donkey. Well done, all of you. Let's move on. Okay, now I want to do a bit on centripetal force. Okay, now I need you all to understand one thing. Okay, let's do a short revision on centripetal force. I know many of you would like that, right? Okay, let me know in the chat. Okay, so now I need you to know that centripetal force, all right, so centripetal force is a form of resultant force. Now, and I'm sure you all know that resultant force is brought about, okay? Resultant force is brought about by acceleration, okay? Now, what is acceleration? Acceleration is the rate of change of velocity. Do you all know that? So, let me reinforce a little bit. When your velocity changes, you get acceleration, and when there is acceleration, the object experiences resultant force. Okay, and centripetal force is resultant force. Now, I need you to understand that velocity is a vector quantity. Now, velocity is a vector quantity, which means that it has, what is a vector quantity, guys? Yeah. What is a vector quantity? Can you put down your answers? What do you think is a vector quantity? Yeah, what do you think is a vector quantity? Let me know in the chat. Yeah, you have very good. So it's not very delayed, guys. Okay, so you have magnitude and direction. You're absolutely right. Now, magnitude of velocity is otherwise known as. Now, the magnitude of velocity has a more common name, and it is usually known as. Let me know. Key your answers in. No, no, no. The magnitude for velocity is known as speed. Okay. So let me get this straight, right? Okay. So this is the revision for you. Please listen. Now, um, let's say the speed did not change. Okay, the speed stays constant, but direction changes. All right. That would mean that velocity changes. And that would mean that there is acceleration. And that would mean that there will be a resultant force, which is centripetal force. I'll go through this one more time. Yeah. Now imagine your speed does not change, because we are very familiar with acceleration when speed changes. But in centripetal force, it could be that the speed does not change. All right. So the uh, direction changes, and then the velocity changes, which means that there will be acceleration. All right, and you will get a resultant force, which is centripetal force. Now I want to move a little bit more on centripetal force. Okay, now so centripetal force, all right, we know. Okay, so for centripetal force, all right, we know that it is perpendicular to the motion, and it is always acting towards the center of the circle. All right, so these are the two important features of centripetal force. Okay, for example, if the object is moving in this direction, you can see that it is not a straight line. So therefore direction changes. Therefore there is acceleration. Therefore there is resultant force, which is centripetal force. So centripetal force will act this way because this is towards the center of the circle. and this is perpendicular to the motion of the object. So can I know the answer to this question? Key it in the live chat. I'm looking. What do you think is the answer to this question? A, B, C, or D? What do you think? Okay, let me know. So the answer to this question is B. Now, this is because if the satellite is orbiting Earth, uh, Earth would be the center, correct or not? So then the centripetal force is towards the Earth, which is the center of the circle. Yeah. So B. Yes, Jared, Kylie, Kenjin, well done. Let's move on to our next question. And if you got any uncertainty about centripetal force, do write them down in the chat. Okay. All right. This is the question that students will get stuck in, and then they will try to resort to some formulas that is not within IGCSE to solve the question, which you're not supposed to. Right now, within a particular syllabus, you are just supposed to use everything within that syllabus. The fact that you pluck out some formula from AdMaths and from another exam board, another syllabus, then it's defeating its purpose. Yeah. Okay, of course, it's not wrong, it's great, right? If you are in the exam and that's all you can do, please do that rather than leaving the question blank. All right, but now that we are learning, I want you to think about this question. Please attempt this question. Yes, again, we have done this question many times, Jared. So make sure you give me the correct answer. Kylie, do you know the answer, Kylie? Maybe you can try. Yeah, Dion. All right, I think I hope you have some calculations to back that up, Dion. Now you can please attempt the question. Okay, I see Kenjin's answer. Very good. Now, what is the easiest way to get the answer? Okay, and remember one thing, right? Whenever you're faced with a difficult question in paper two or with any paper, all right, you need to move on. Okay, you can't be spending so much time over a particular question, all right? So now, how do we go about this question? So now, for this question, it's using the conservation of energy, the conservation of energy principle. So the GPE, all right, equals to the kinetic energy. So the GPE is mgh, okay, and the kinetic energy is half mv squared, all right. So we are going to cancel off the m, all right. Now, since the question is about, if you look at the question, it's about the, okay, now first of all, we need to eliminate certain answers. Okay, a very good skill in attempting multiple choice questions is to eliminate the answers that are absolutely wrong. Now, the fact that they have asked you to ignore air resistance, okay, the fact that they have asked you to ignore air resistance, it really means that um, Yeah, mass does not play any part. Okay, the fact that they've asked you to ignore air resistance means that they have already, you already know that C and D is wrong. Okay, so now the issue is with the height. Okay, how do you know that mass does not play any part? Look at the equation, the principle of the conservation of energy equation. You cancel off the m. It means that, doesn't matter what mass you use, you will get the same result. So it's not about the mass, right? So it's about the height. So it's half v squared over g. So we'll be using this formula. Now let's work it out with what is the height when the speed is 3 meters per second. All right. So what is the height? So the height is 3 squared over 2g. All right. So it is 9 over 2g. That is the height when the speed is 3 meters per second squared. Now, what change would result in a speed of 6? Okay, so now if we change the speed to 6, it will be 36 over 2 grams. Now, it will be expedient for you if you do not, if you leave it with the same denominator. So then the comparison is very simple. So this is increased by a factor of 4. That is how we know the answer is B. So when you increase the height to 4 times, that will give you a speed that is double. And this is how you answer this question. So please, if you have any questions, please key them in. I'll be looking at the live chat. Any questions to this? I can see you all are very happy that you have selected the right answer, but the way to do it, I hope you all have the proper way of doing it, yeah? Okay, we'll move on. If you have any questions, please send them my way and we'll move on now. All right. So now we have moved on to, yeah, we are moving on to the second topic. Remember, there are 4 topics, right? So now we are on the second topic. So it's thermal physics. Okay, so the question is, the temperature of oil rises faster than that of water. Why? Now, it is very clear that the answer is either B or D, because A and C it totally doesn't make sense. Okay, the boiling point does not determine the rate of the rise or the drop in temperature of any object. So it's the thermal capacity. So if the temperature of oil rises at a higher rate, it means that the thermal capacity of oil is smaller. Now you need to just remember this. Okay, if you have a smaller heat capacity, okay, now what this would mean is that the temperature changes, at a higher rate. So objects like sand, all right, oil. Now, if, for example, metal, all right, now these objects that I mentioned, all right, their temperature changes very easily, very rapidly. So when the heat capacity is small, all right, think about it as a storeroom. Once the storeroom for heat is filled, it has no choice but to increase its temperature, as opposed to an object with a large specific heat capacity. Imagine the storeroom for heat is so great, so it can store a lot of heat, a lot of heat, a lot of heat without the change or the rise in temperature. So objects that changes temperature very slowly, yeah, they have a large specific heat capacity. So just remember that. Objects with small specific heat capacity, the temperature changes very quickly. Objects with large specific heat capacity, the temperature changes slowly. Okay, I hope this is clear. So D is the answer. Very good, Kylie. D. All right, we'll move on. If you have any questions, please send them my way. Moving on. Thermal physics. Now, remember, all right, you need to learn to eliminate the answers that are just plain wrong. Okay, so in this case, I hope no one selects A because molecules do not expand. The object expands, but the molecules themselves never expands. The atoms never expands. All right, you don't expect the atom to grow in size. No, when an object expands, that means that the atoms, the molecules, they have moved further apart. So A is absolutely wrong. Okay, so let's look at A, B, C, and D. So in this question, A is absolutely wrong, but I think a lot of students will choose that answer. All right. Now, when the gas is heated, they hit the wall less often. I mean, it cannot be, right? Because they are moving faster, definitely they will hit the wall more often. So it doesn't make sense for B to be the answer. Now, good students will be a little bit torn between C and D. Okay. Now, why is the answer not C? So why is the answer not C? Can I have your reasons in the chat? Why is the answer not C? Let me look at your answers. Remember my question, why is the answer not C? I'm telling you that the answer is D for this question. So why is it not C? What is wrong with C? Okay, I'll have a look at your answers. Now, the answer is not C because in the question, it tells us that there is constant volume, meaning the volume of the container is fixed. Now, if the volume of the container is fixed, the molecules cannot move further apart. So that is the reason why the answer is D. So now, yes, Kenjin, you are right. Kenjin states that because they don't have any more space to move. You are right. It's because of the constant volume of the container. The container does not expand. And that is given in the question. Thank you, Kenjin. Now let's move on to our next question. This could very easily be one of the toughest specific heat capacity and specific latent heat questions. So I want you to give it a go before I actually give you the answer. So I want you to try. Uh, Personally, I have not tried it. All right. So, and I want you to key in the answer in the live chat right away after you have done your calculations. Let's have a look. Please let me know that you are doing the question. Okay, so I'm going to slowly attempt the question to help you. Okay, I'm not getting any answers yet. Remember, if you get the answer, can you please key it in the chat? Okay, I'm going to slowly attempt the question now. So now you have 100 grams of water, and the temperature of the 100 grams of water is 25 degrees Celsius. Now what's happening is that you are going to be given 50 grams of ice. All right, remember to ask any questions that you have. Now, so the water is giving heat away to the ice, and the ice is accepting the heat. So remember, we assume that there is no loss of energy. When we do our calculations, we have to assume that there is no energy loss. And the story goes on to say that now for the 100, okay, I see some answers coming in. Thank you for trying. Now, when the water's temperature has dropped to 0 degrees Celsius, they tell us that we have 18 grams of ice left, less than before, which means that we have 32 grams of ice melted. So 32 grams of ice has absorbed the heat from the 100 grams of water. All right, so then you're gonna get some water, but it's immaterial. So now we are going to use the equation energy given equals to energy absorbed. All right. So energy that is given out by the water. So the water, the temperature changes. So we are going to use mc delta T. And for the energy that is absorbed, the ice did not change temperature. It's a change of state, right? So it's not specific heat capacity. It is specific latent heat. So this is going to be ml. So remember that this is ice and this is water. Do you all follow so far? So for the mass, we got to use the mass of the water. The C, we got to use the C of the water. And the temperature change is 25 because the temperature did change from 25 to 0. Is that clear? Yeah. If you have any questions, please continue asking them. Now, the energy absorbed by the ice. Okay, so the energy absorbed by the ice would be the mass of ice that melted, which is 32 times L. So then you find L, and that would be your answer. So is the answer A or B? I'm getting a lot of A's and B's. And the answer is B. So, well done, Kenjin. Well done, Kenjin. So, for Kylie and Dion, and for the rest who are not trying, I hope that I've helped you to understand this question. Okay, but Kylie and Dion, thank you for trying. Now, if you have any questions regarding this particular thermal physics question, please send them my way. Very good, Jared. That's what I got. So the nearest answer would be B. Are you okay so far? Can you all follow? Am I too soft? Okay, so I hope you can follow. If there's anything that I can do to make you feel more comfortable, please put them in the chat. Now this is a very simple question, but a lot of students tend to get them wrong. Now, can you please spend about 1 minute to read and come up with the answer and key your answer in? Thank you, Jared. So thank you, Kylie. So I know that everything's fine. Okay, now read this question and key the answer in. Can I see some answers? Like I expected, all of you are not getting the right answer. No, it's not A, it's not B. Okay, so now I just want you to understand something here. Okay, now whenever, yeah, now whenever an object feels cold, usually it's a conductor. Listen carefully, yeah. So whenever an object feels cold, it is usually a conductor. Why? Because it is conducting heat away from your hands. I hope this is clear. So when an object is just, like if you touch a piece of wood, it very seldom the wood will feel cold, right? Okay, because the wood is not a good conductor and it's not conducting heat away from your hand. All right. So the answer to this question, let's look at it. A, B, C, D. Now, of course, immediately you can rule out A because definitely plastic is not a better thermal conductor. All right. And C is also not. So you know that it's definitely B or D. A and C cannot be the answer. Okay. A and C cannot be the answer. So the answer is either B or D. So it is whether the metal and the plastic are at the same temperature. They have been left out in the night, in the same place for hours. They have the same temperature. So the answer is D. Just like in your classroom, when you touch the tabletop, you don't feel cold, but when you touch the legs of the table, which is made up of metal, presumably, it's cold. All right, why? But they are at the same temperature. All right, they are at the same temperature. You did not know that, now you know. They are at the same temperature, but why does the metal feel colder? Because it is conducting heat away from your hand. I hope that that is clear. So if there's any question, please, all right, send them my way. Okay, now we are preparing for the next question. Yeah, the next question. Yeah. Have a read through the next question. Okay, so now let's attempt this next question. Now, um, the features of a liquid in glass thermometer. The features of a liquid in glass thermometer. Right. Number one, it is responsiveness. Now, responsiveness, responsiveness is what many students think is sensitivity. It's not sensitivity. So if a thermometer can reflect the correct temperature of the object that it's measuring, we say, oh, it's sensitive. No, it's responsive. Here in this topic, sensitivity means another thing. All right, so there's responsiveness, there is sensitivity. All right, there is range, and there is linearity. So now, make sure you know all of this. All right, I'll just mention it briefly. So responsiveness is how fast, the rate you can reflect the correct temperature. Sensitivity is the distance moved by the liquid per unit temperature change. So when I say the thermometer is more sensitive, all right, for the same unit of temperature, 1 degree Celsius, it moves more. All right, so now if the liquid moves more, all right, definitely it's more accurate, you can see it clearly. All right, then we have range. Range is the difference in distance between the highest and the lowest temperature that the thermometer can measure. And linearity means that for every unit of temperature, the distance moved by the liquid is the same. Okay, so you need this for. And can I have the answer to this question? Can you please key in the answer to this question? Okay, I'll check the chat in a while. Yes, very good, guys. So the answer to this question is number 3. All right, let's look at number 1. Um, a liquid which expands linearly when heated. So for number 1, uh, it's talking about linearity. It's not talking about sensitivity, right? So number 1 is not the answer. So look at the choice of answers that you have now. So if number 1 is not the answer, definitely you have ruled out A and B. That's what I mean by you eliminate the answers that are definitely wrong. So you're left with C and D. And now we just have to determine whether number 2 is right or wrong. Look at number 2. The thickness of the glass wall will affect the responsiveness. So the thickness of the glass wall will affect the responsiveness and not the linearity. So the answer is D. Very happy to see many of you choosing D. Very good. Now we'll move on to our next question. Obviously, I've pressed the wrong button. All right, we're moving on to topic number 3, waves, light, and sound. Can you all try this question? Okay, I would like to see the answer to this question. Um, Now, in order to do this question, you need to know the formula for frequency. All right, what is the formula for frequency? Or what is the definition of frequency? Okay, with regards to waves. Okay, and I would like to bring your attention to another definition that I think you should know when it comes to this topic: waves, light, and sound, which is period. So can you quickly key in the definition of frequency and the definition for period? Can I see your definition for frequency and your definition for period? Come on. Wow, that was quick. Thank you. So for frequency is the number of waves per second, Jared says. So yeah, number of waves. Can I have the definition for period, please? So based on Jared's definition, the number of waves per second, this is the formula that we need to use. Okay. Now what about period? No. Sorry, Jared. Can you try again? What is the definition? Anyone here knows the definition for period of a wave? Anyone wants to try? Well, it is actually the time for one wave. All right, so it's the total time divided by the number of, correct. Okay, yes. So I would like to bring this to your attention. So how do we solve this question? We use the formula here. So in this case, frequency is the number of waves, which is 6, over time, which is 2 minutes. So we got to change it to seconds. So it is 6 over 120. All right, so the answer is A, isn't it? Very good. So I think this is the formula that you should pay attention to for this question. Okay, good. So don't get into some bizarre and complicated calculation. All right, next one here. Yeah, it irks me, when students get this wrong, because it's so plain and simple. This is a plain mirror, right? It's a very simple question. Can I see your answers, please? Can I see your answers, please? Now, again, let's look at this question. All right. Now, let's look at A, B, C, and D. Guys, I hope that you all know that in a plane mirror, it is definitely a virtual image. A virtual image, right? So definitely A and C is wrong. So it's either the position is at 1 or 2. All right. Now I want you to understand something. Okay. I want you to understand something. If the object is here, all right. Now the image for a plane mirror, okay, um, will be along the normal to the mirror from the object. I will repeat that, yeah. The image for a plane mirror is along the normal, okay, along the normal of the object to the mirror. For example, this is the normal, and the image will be on this line? So definitely the answer is B. Remember, the image will always lie on the normal of the plane mirror. So I hope that is clear. Yeah. Now, can I go a bit further? Okay. Do you all know how to draw the image, the ray diagram? Do you know how to draw the ray diagram? All right. Let me just illustrate. Very smart here. So remember, I mean, although this is paper 2, but you know, sometimes when they come up with the ray diagrams, students may also find it difficult. Okay, they can't recognize. So you draw two lines, all right, and then from an image, the suitable one, you draw dotted and go, and you draw dotted and go. So this is your eyes, and therefore your eyes will view the image there. And it is virtual because it's not there, right? That's why we represented it with dotted lines. So I hope this question is good. All right, so I'm going to move on. Thank you, Liu, for participating. Jackie, yes, thank you. So we're still waiting for Carl. Carl is participating. What about Junsi? Is he even here? Huh? Moving on. Yeah. Now, as you are reading the question, let me give some comments. Now, I hope you know the three wave phenomena that you learned. Okay, what are the three wave phenomena that you learned? So we learned three phenomenons. Okay, what are they? Can you please key them in? So my question is the three wave phenomena that you learned. What is the first one? So the first one is reflection. So what's the second one? Very good, Dion. Very good. All right, your answers are coming in. Kenjin, not rarefaction. Yeah, rarefaction is a different thing. Yeah. So first we learn reflection, refraction, and then diffraction. Okay. So, well, reflection, you know, it's pretty obvious. Now, refraction is about the waves going into medium of different densities. Okay, usually solid to liquid, liquid to gas. Now, diffraction is talking about bending, bending. Can I know the answer to this question? Key it in. Now, when I was teaching this topic, you know, we separated into obvious and non-obvious diffraction. So we categorize diffraction as obvious and non-obvious. So I hope you remember, you know, what are the characteristics of waves, okay, that will more likely go through obvious diffraction, or in IGCSE, they just call this more refraction, and this one is just less refraction. So that diffraction, sorry. So yeah, what is the characteristic of the wave that will go through more or less diffraction? Very good, Jared. The answer is A. Yeah. So now, in order to have more diffraction, the wave should have a larger wavelength. Thank you, Kylie, for joining us. All right, thank you. Okay. So yeah, larger wavelength. Okay, and this is nothing, this is not the gap, right? This is an obstacle, but Yeah, in order to have, if you're talking about gaps, which is the more common question on diffraction, you would rather have smaller gaps. Okay, you would have smaller gaps. Now, if you are going for non-obvious diffraction, then definitely you just write the converse, right? Which is smaller lambda and a larger gap. So Jared is right. In this case, the answer is 8. Well done. Okay, moving on. So this is diffraction. Still on this topic. Now this, a lot of students found this very challenging. I just want to know what your answer would be. Can you just read the question and write down your answer, key in your answer first? All right, let me just do a short revision on this topic. So this is electromagnetic waves, and electromagnetic waves, they all travel in vacuum. All right, they all travel through the vacuum. They are all transverse waves, and they all travel at the same speed. Yes, yeah, you are right, Adam. The answer is D. So this, a lot of students will be confused about this because they would link the higher frequency waves with higher frequency along the spectrum to be more penetrating. Okay, no. So for this question, it's quite clear cut. It's all playing on the speed. So the fact that the moon comes in between, right? So, well, the infrared radiation, ultraviolet, and visible light from the sun all disappear at the same moment because we assume, all right, that the speed of all electromagnetic waves are the same. So I found this question a bit tricky. All right, so the answer is D because they are saying that all waves travel at the same speed. Okay, well done. Moving on. So this one has to do with sound waves. So I hope you know for sound waves, the loudness, all right, let me just write this down. So for sound waves, the loudness, right? So the loudness of the sound, all right, corresponds to the amplitude and the pitch. So the pitch of the sound corresponds to the frequency. So in this case, looking at this question, um, is the frequency the same or the amplitude the same? Which is the same for this question? Is the amplitude the same or the frequency the same? So, so remember, the higher, the greater the amplitude, the louder the sound, the higher the frequency, the higher the pitch. So I hope you know what characteristic is the amplitude, how is it featured on the graph, and how is frequency featured on the graph. Yeah, yeah. So yeah, yes, you guys are right. So amplitude stays the same, so the loudness stays the same for this question. So since the loudness stays the same, thank you guys, since loudness stays the same, automatically we know that the answer is either cat or donkey, right? And Jared has selected donkey. Yeah, so between sound 1 and sound 2, all right? So you are right, Jared. D is the answer, okay? The higher the frequency, which is sound 1, you get more waves. The lower the frequency, you get less waves, all right? So sound 2 has less waves, so lower frequency, so lower pitch. So the answer is D. Well done, Jared. Moving on. Now we are moving on to the second last topic, which is electricity and magnetism. So this is a very tricky question. Very tricky. So can you read and key in your answer? Now, reading through this question. Dion says C. Very good. Why would you think the answer is C, Dion? Now, whether or not the nail becomes a permanent, the strength of the permanent magnet, which is the nail, all right, on, it depends on the number of paper clips attached when the bar magnet is not there. All right, so I hope you know the difference between soft and hard magnetic material. Okay, so soft magnetic material, okay, yeah, so very good. Yeah, so soft magnetic material would be A, because it totally lost its magnetism when the bar magnet is removed. So when the bar magnet is removed, all the clips all fell. So A is soft magnetic material. Okay, now the nail that is the strongest permanent magnet is C, because you're looking at this. So this does not matter. Okay, this actually does not matter. All right. Yeah, you got to look at the highest number. Yes, and for C, only one. Compared to this one, you've got 3 dropping. All right, that means C is the better permanent magnet. Well done, guys. Well done. Yep, Kenjin, you can hold more clips when the bar magnet is removed. Okay, so that's important. Moving on. Now, this is one good question for me to illustrate the effectiveness of eliminating wrong answers. Okay, when the answer is like clearly wrong, automatically you need to cancel them out. When you automatically dismiss the answers that cannot be the answers, your chances of getting the answer right increases dramatically. All right, so what is the word that we look out for when we all attempt transformer questions? What is the word that we look out for? Okay, now the word to look out for when we are dealing with transformer type questions is whether it is using AC or DC. Now a transformer, if you did not know, now is the time that you know, transformers cannot uh, work with DC. Transformers cannot work with DC. So looking at that, well, you have A, B, C, and D. Okay, so definitely DC is wrong. So B and C is totally out of the question. All right, so B and C is totally out of the question. So the answer is either A or D. Now, if your primary coil is 15,000 and your secondary coil is 750, definitely it is step down. But A is step up, right? A is step up. So automatically you know the answer is D, and you can read just for double confirmation. Yeah. 240 to 12 volts. So that is a step down. So D is your best bet. Okay, so that's how you attempt this question. Remember, so transformer does not work with DC. Okay, have a look at the next question. Thank you, Dion, for participating. Well done. It's D. All right, so this is a question that gives a lot of headache to many people. So please read and attempt and tell me what do you think the answer is in the chat. What do you think, guys? Now, let me do a very quick recap on this topic. Okay, so this topic is about resistivity. Okay, the relationship between resistance and the length of the wire, the resistance between the relationship between the resistance and the cross section area, and yeah, basically these two. So what is the relationship between resistance and the length and the resistance and the cross sectional area? Okay, so um, we have resistance directly proportional to the length, okay, and we have resistance inversely proportional to the area for this question. So let's look at this question. Okay, first it was 100 centimeters, okay, and now it is 50 centimeters. So this is definitely reduced by a factor of 2. Now the area, so the area is 0.2 mm squared, okay, and now the area has become 0.4 m. Thank you for trying, guys. You all think the answer is A, mm squared. So this is increased by a factor of 2. So usually how do we do this question? So remember the resistance, okay, so the resistance of the second wire, okay, is the resistance of the first wire. Now, now resistance is directly proportional to length, okay. So when the length is cut into half, so we say that the resistance has reduced, okay, by 2. Okay, reduce, so multiply by half. Now when the wire is thicker, guys, when the wire is thicker, okay, when the wire is thicker, resistance goes up or down? When the wire is thicker, the resistance goes up or down? Let me know. Does resistance increase when the wire is thicker, or the resistance decrease when the wire is thicker? What do you all think? Let me see in the comment section. So, since resistance is inversely proportional to area, and since area has doubled, that means that the resistance must go down by 2. Go down by 2. All right. So, yeah. So Kenjin is down, it's decreased. Very good. So since it's decreased, we need to multiply it with a half again. So yes, the answer is 2 ohms, and the answer is A. Jackie, Kenjin, thank you for trying. Well done, Jared. Ticker is increased. All right, very good. Wow, very happy with this. Very good. This question used to be very difficult, right? But I hope that you have found a way. All right, moving on. All right, have a look through this question and we will attempt it shortly. Okay, now you are given 3 resistors, okay, and they are in parallel. So this is a cell for you, and now you've got 3 in parallel. So let's say this one is 1 ohms, 2 ohms, and 3 ohms. Okay. So now, shall we eliminate the very, very obvious wrong answers? So I hope you know that this is a parallel circuit, so they all have the same voltage. All right, they all have the same voltage. So B is definitely wrong because we know that the voltage is the same. So C is also wrong because it is insinuating that the voltage is different. And you know, I mean, just by reading, you know that D is also wrong. Because the potential difference across each resistor is the same as the electromotive force. For example, if this is 6 volts, all right, this will be 6 volts, this will be 6 volts, and this will be 6 volts, right? So definitely D is wrong. So the potential difference across each resistor is the same. So B is wrong, and C, the potential difference across the 3 ohm is greater. So I haven't even read A, you know, and I know that B, C, and D is wrong. So the answer is A. But the current in each resistor is different, but the potential difference is the same. Automatically, you know the answer is A. Now, I want to ask you all a question, and I wish to read your comments after this. Now, uh, now, what is the relationship, okay, between the currents in the 1 and 2 and 3 ohm resistor respectively? What is the relationship between them? All right. To make it simpler, what is the relationship between the current in the 1 ohm and the current in the 2 ohm resistor? Can I see your answer in the comment section? in the chat section. Now, I hope you know that the greater the resistance, the less current can flow through. Okay, I hope that is clear. So assuming, all right, we have 6 amps going in here. Now, the resistance is doubled. Okay, so the resistance is doubled. So you're going to get half the current. Remember that now you're going to get half the current because the resistance is doubled. Come on, all right. Yeah, so you're going to get 3 amps. Now it's a bit more difficult to compare 2 ohms and 3 ohms. So let's just compare 1 ohm and 3 ohms. Now if the resistance is 3 times greater, that means the current is 3 times down. So how much current in the 3 ohm resistor? 3 times lower than the current in the 1 ohm resistor. So how many amps is that? It's 2 amps. So this is just a further explanation to this question. The answer is A. Okay, if you have any questions, please go ahead. Any questions? Well done, Kenjin. I saw your answer. Yes, it's 2 amps. Very good. I can see that you're improving. Well done. Well done. Any other questions? Any uncertainties about this topic? So we'll move on. This is a tough one. Okay. So I need you to understand one thing here. I need you to understand one thing. So this is potential divider. Okay. So now in potential divider, all right. So you are given this resistor. Now I hope you understand one thing. Okay. I want you to understand that here you have more resistance. So if you have more resistance because the length is greater, then you will have more potential difference. I hope this is clear. Okay. And this one is shorter, so then you get less resistance here, and therefore you will get less voltage here. I hope this is clear. Okay, I hope this is clear. Now, what will happen to the brightness of the lamps when K is moved a short distance towards X? So the question is saying now it's moved towards the top. Okay, so if I have a lamp here, all right, then compare the brightness with the lamp over here. Okay, so this is L1 and this is L2. What do you think the answer is? Let me know in the chat. So if you move the contact further up, you're going to get less resistance, so you're going to get less voltage. And here you're going to get more voltage. And I need you to understand that the brightness of the lamp, yes, it depends on the current and it also depends on the voltage. So try not to bring current in because, yeah, I think using voltage is sufficient to give you an answer to the question. Okay, so you get less voltage, so therefore L1 will be, let me see your answers, guys. Show me your answers first. Show me your answers. C, Dion. You are absolutely right. Okay, so the answer is C, because the answer cannot be D, right? It cannot be dimmer and dimmer because this is a potential divider. One gets less, the other gets more. So yes, the answer is C. This will be definitely brighter and this will be dimmer. It corresponds to the voltage across the length. All right. Well done, guys. Well done. I see your answers. Very good. Now we are moving on. Okay. So of course, electricity and magnetism, usually they get more spotlight in the paper. So of course, the questions here is more, and I think this is the last one. So have a read through and slam your answers in the chat. What's the answer for this AC generator question? Okay. B. Yes, you're absolutely right. Well done, Kenjin and Jared. Okay. So, looking at the graph, okay, so this is time and this is voltage. Okay. So, yeah. So, in order for this to happen, all right, it needs to turn 360. So, this is 180, this is 270, and this is 90. So, this is positive 10, okay, and this is negative 10. So, yes. So 90 to 270, that is 180 degrees. So the answer is B. Okay, now okay, so yeah, the answer is B. Finish, done. All right. So now, all right, I want you to answer me the ones in red. All right, does this happen in red? All right, the ones in red, does this happen when the coil is horizontal or vertical? So can you please key in red vertical or red horizontal? Okay, and the ones in black, do let me know, does this happen when the coil is vertical or horizontal? So key in black vertical, black horizontal. All right, I want to see in the chat. I repeat the question, yeah. The red dots here, does this happen when the coil is vertical or horizontal? So key in red vertical or red horizontal. And the black dots here, all right, does this happen when the coil is vertical or horizontal? So key in black horizontal or black vertical. Now, I hope for you to understand that this is zero EMF induced. And zero EMF induced, it means that the coil is vertical. So red is vertical. Because when the coil is vertical, it is not cutting any magnetic field lines. Please, yep, make sure you do your revision. And for black, It's maximum EMF induced, and when it is maximum EMF induced, it is at the position where it cuts the most number of magnetic field lines, and that happens when the coil is horizontal. Now, I hope you got that. Now, if you did not get that, please key inside the chat. We need a further deeper explanation to this, and I will draw more diagrams. If not, we are going to move on. Yes, hello Miyoko. Black horizontal, red vertical, absolutely right. Yeah, Dion, yeah? Red vertical, black horizontal. Finally, you all are getting it. Now, if any of you don't understand, please key in the chat and I will draw more diagrams for you, all right? Oh, we got one more. Okay, but let me linger here a bit. Yeah. Yeah. Hi Miyoko. I'm a bit I don't understand your question. Can you clarify your question? Or if anyone understands what she's asking, can you clarify her question? Because I got a bit of a trouble understanding her question. Hi, Miyoko. Oh, ah, sorry. Yeah, I got what she's saying already. Yeah. Yeah, you can. Yeah, it's actually very. What I'm asking is very obvious in the question, right? Because, yeah, yes. So the short answer to your long question is yes, Miyoko. It's very obvious in the question. Well done, well done, well done. Yeah, but anyways, whether it's in the question or not, guys, maximum EMF induced coil is horizontal. No EMF induced coil is vertical. Right? Yeah, thanks, Nyoko. I finally understood that. Very good. So now let's move on to the next question. This can be quite tough. Now, year 10s who are with us, if you can follow up to this point, you can more or less feel that, your completion in the syllabus is at hand. All right, so exciting times, exciting times. Again, another potential divider question. When they changed the syllabus in 2016, yeah, more and more spotlight is given to potential dividers. Right, so okay. So now this is what they want, yeah. They want the potential difference across Y to increase. So they want the voltmeter reading to go up when the temperature goes up. Okay. So you must understand that when, okay, for a thermistor, guys, for a thermistor, okay, when temperature goes up, what happens to the resistance? When the temperature goes down, what happens to the resistance of a thermistor? So the symbol for a thermistor looks like this, yeah. So what happens, okay, to the resistance of the thermistor there? So now when the so just, what I find really helpful is when the temperature goes up, resistance goes down. When the temperature goes down, resistance goes up. It even works with the LDR, guys. You see, LDR is talking about light intensity. So when the light intensity goes up, what happens to the resistance? When the light intensity goes down, what happens to the resistance? And it's more or less the same. Yeah, thank you guys for your participation. So when the light intensity goes up, resistance goes down. When the light intensity goes down, resistance goes up. So it's more or less the same. So this is how, I encourage students to remember the relationship between the physical quantities. So when the temperature goes up, the resistance of the thermistor goes down. So you definitely will not put the thermistor here. You will put the thermistor here. So when the temperature goes up here, okay, resistance goes down and voltage across it goes down. That means that the voltage here will go up. So thermistor at X and the resistor at Y. D. Okay, so when the temperature goes up, resistance goes down, voltage goes down, more voltage over here. So here is the resistor. So the answer is D. Almost all of you got it wrong, right? And any question about that? Do you want to see that for a bit longer? Any problems? Now, if you have a question, please. So potential divider, just remember, voltage drops here, voltage increases here. It's like that because they share the same amount of voltage. It's a series circuit, basically. It's essentially a glorified series circuit question. Okay? Okay, sorry. Okay, I'll explain the whole thing again. All right, I'll explain the whole thing again. Now, this is X, all right? It is connected to the voltmeter. What is connected to the voltmeter? Y. So they are asking you, okay? So they are asking you what should be what should the arrangement be? But this is what I want. When the temperature goes up, okay? When the temperature goes up, I want my voltage of this voltmeter to go up. Well, you have to put the thermistor here because when the temperature goes up, the resistance of the thermistor goes down, so the voltage goes down. So therefore, the voltage of this voltmeter will go up. So definitely the thermistor must be here. What about this side? Well, just put a resistor. Okay, one last time. Temperature goes up, resistance goes down, voltage goes down. So a normal resistor that's here, the voltage across the resistor will go up as reflected in the voltmeter. Is that clear? So remember, potential divider, very tricky, but once you get the hang of it, not a problem. So remember to look for potential divider questions only in the later years, yeah, because that's when they really focus on it. Yeah. Okay, I'm moving on. Oh, right. So this is a, guys, can you just key in the, okay, Miyoko, yeah, can you please key in the chat, right? Whether this is a induced force or induced current question. I repeat, yeah. Can you please key in? I want to know whether you think this is an induced force or an induced current question. Yes, it is an induced force question. Okay, so what do you think the answer is? Key it in. So for this one, you have to use your Fleming's left-hand rule. All right, this is Fleming's left-hand rule. Um, I'm going to try to use the Fleming's left-hand rule. So this is, whoa, okay, it's just not possible, right? Yeah, okay. So this is your thumb. Your thumb represents your, okay, I need smaller hands, right? The thumb represents the induced force, all right? The index finger represents the magnetic field. So this is north and this is south. And this is the direction of the current. Okay. So this is north and south, and automatically you know that I'm pointing in the wrong direction. Okay. So my index finger needs to point the other way. Okay. But this current is pointing in the right direction. Okay. See the index finger, this is north, this is south. It's supposed to be pointing the other way because the question is the south is on our left, right? But the current is pointing in the same direction as the question. So how do I change the index finger's direction without moving my middle finger? Okay, so I need to, so I remember, so I'm like holding my middle finger so that it doesn't change direction, but my index finger is pointing the other side. Whoa, I'm having difficulty, guys. But yeah, the answer is A, towards the bottom of the page. Yeah. If I can display using my right hand, I do not know. Yeah, yeah, yeah. But this is the right hand, so it's wrong, right? Okay, so my thumb is wrong. So this should be your left hand, and your north and your south is here, and the index finger. So if this is your left hand, you will find that your thumb is pointing towards the bottom of the page, right? Yeah. So it will look like this. So and then your thumb will be pointing down. So the answer for this question is A. Did you all get that? Do you all know how to use your left hand? Okay, so Fleming's left hand rule. So remember your fingers, all right? So the thumb represents the induced force. The index finger represents the current, sorry, the magnetic field, so north and south. And this middle finger here represents the current. And all three fingers must be perpendicular to each other. All right, they must be perpendicular to each other. Okay, moving on. Sorry, Miyoko, is there something that you want me to clarify? Okay, I'm going to move on. This is a bit of an advertisement. Okay, so if you know anyone in year 10 who wants to finish the syllabus a bit quicker, so do join the Atomic Physics seminar that is happening on the 5th of December. Okay, and this will be an introduction to what we're going to do next, atomic physics. All right, and we know whose favorite topic this is, right, guys? Put it down in the chat whose favorite topic this is. And also answer the question for number 5. Key in your answer. Yes, Jared, why are you screaming? Okay, I want you all to attempt this question. Okay, what do you think the answer is? So I want you all to understand, right? So whenever you go through half-life, remember the answer that you get are the atoms that have not decayed, you know. Right? Look, 8 times 10 to the power of 10. All right. So the year tens, I think you are lost here already, so you can leave the live or you can just watch us. All right. Now, if you go through half-life, okay, if you keep on going through half-life, now I need you to understand that the answers here, they are the atoms, they are the radioactive material that has not decayed. Okay, so now they're asking you for the sorry, I shouldn't use the word atom, right? It's the nuclei. Okay, the nucleus. So plural is nuclei. So this will be the number of nuclei, the nucleus that has not decayed. So how do we get the ones that has already decayed, right? So definitely you've got to take 8 times minus 1. So the answer will definitely be 7 times 10. So just be careful. Whenever you're attempting atomic physics, right, please be careful. Ask yourself, do I need to minus? Do I need to minus? So remember that. So yes, the answer for this question is D. Well done, Kenjin. Well done. Wow. Okay. Wow, Miyoko, you have done this already, is it? Okay. Moving on. So if you have any questions here, please put it in the chat. Moving on. So I have purposely selected, of course, challenging questions. Okay, very challenging questions to this topic. Can I have your answers, please? Can I have your answers? Okay. Well done, Miyoko. All right. So now, is anyone going to try to answer this? Wow. engine. That's very good. So now let me work it out for those who are not sure. So remember the half-life is 10 minutes. The background count is 20. So remember, background does not go through half-life. So that's the important thing that you need to know. Background does not go through half-life. Okay. So what you need to do is the first step is you got to take 1000 minus 20. So you're going to get 980. Correct. Now, this is the count rate due to the source alone, and it does go through half-life. So 980, all right, divided by 2, which is 490. So this is due to the source alone, but the detector picks up the count rate due to the source and the background. So the detector will pick up 490 plus 20, so it's 510. Therefore, the answer is a C. Well done for those of you who got it. Absolutely amazing. Yeah, so those are the steps, yeah. So you got to take out the background radiation to find out the count rate due to the source alone, the radioactive material. Then you got to divide this by 2. All right, so that's 490. So after 10 minutes, after the half-life, the source is only giving out 490, but the detector picks up the 490 and the background, because background is perpetually over there. So it definitely will always pick it up. So when the count rate has dropped from 1000 to 510, you know that half-life has taken place. I hope this is clear. Moving on. Right. So I wanted to show you a variety of questions. So remember, the danger about paper 2 is that it can be a, if they ask you the same question in paper 4, it can be a 1-mark question in paper 4, but sometimes it can be a paper 2 question. If they ask you the same way in paper 4, it will be a 3 to 4 mark. It can be a 3 to 4 mark question. Okay, so this is an example of a very easy question. Can somebody just key the answer in, please? Yeah, it's a very straightforward question. Okay, so for this one here, so for this question, you just have to take, so you see the graph is at 2000. All right, so the graph is at 2000. So you just take 2000 divided by 2, so it's 1000. So at 1000, you go and hit, and your answer is 1. So the answer is B. So I wanted to show you that a paper 2 question, a multiple choice question, can be very simple. This is simple because they did not tell us, they did not tell us anything about background radiation. So it's a very simple, straightforward question. Okay, now take a look at the question above. The amount of steps that you need compared with this, okay, but still it's the same mark. So you need to know, you need to be ready. All right, if it's an easy question, well and good, but if it's difficult, it's okay, you get it, you get that right as well. All right, now look at this question. Okay, so this is not that simple. It looks the same, but it is not that simple. So be careful to read from the first letter to the last letter. All right, can I have the answer to this question, please? Can I have the answer to this question? Can I have the answer to this question? No, they have not, Kenjin. You got to do that yourself. Because if you read, Kenjin, right, the graph shows how the count rate registered by a counter. Okay, when they say that, it means that the counter is the detector, and it will definitely detect the background radiation. So it will already detect the background radiation. Okay, so all right, so you have here 45. So what do you need to do? The first step is you got to take 45 minus 5. That will be 40. All right. Second step is you take 40 divided by 2, so it's 20. Then the third step, you got to take 20 plus the 5 again, because that's what the detector is not going to minus out the background radiation for you, 25. So now you got to look at 25 and go and get the answer. And the answer is, all of you got it wrong. It's A. I hope I've made myself clear. All right. Same paper 2 question. All right. The one before is so easy, but this one, if this was asked in a paper 4 question, it would easily be 4 marks. So you got to be careful, right? So the answer is A. Now, we have come to the end of our lesson. Okay, we have come to the end of our lesson. I hope that this method, okay, this video has helped you, okay, to jog a bit of your memory, to clear off any points that are confusing for you. I hope that this video has served as a very good revision tool. And I wish you all the best, yeah, in your physics paper next week. All right, so all the best. And for the year 12 students, I will see you in the live meeting after this immediately to clarify and to bring the lesson to a close. So for the rest of you who are watching, thank you. Bye bye. Any questions, continue to put them in the chat and I'll answer them. Okay, bye bye. Thank you guys. Bye bye. Was a pleasure to have you. Yeah. Bye bye guys. Zoom. Jared. Zoom.